ठीक है, so the first question is कि two fair dice are rolled. What is the conditional probability that at least one lands on 6 given that the dice land on different numbers? ठीक है, तो हमें conditional probability निकालनी है. One on 6 given that both number are different. So first we want the intersection के एक 6 है and दूसरा कोई भी number हो सकता है which is not 6. And then हमें probability चाहिए total के दोनों numbers different थे तो एक number तो it can be 6 and non-6 and it can be both non-6 but like not same numbers. तो पहले वाले की probability है कि 1/6 हमने 6 आ गया और फिर 5/6 कोई और number आ गया and this can happen ऐसे भी कि पहले कोई और number आ गया and then 6 आ गया. And then denominator में it can again be the same situation कि पहला जो है 6 आया, दूसरा non-6 आया या फिर पहले non-6 आया and then दूसरा 6 आया and it can be कि दोनों ही number different आए तो 5/6 into 4/6 and 4/6 इसलिए because जो number 5/6 में से आ गया था वो वापस नहीं आ सकता है. So इसका total we should get 5/36 plus 5/36 over the same thing which is 10/36 plus 20/36 which comes out to be 10/36 divided by 30/36 and इसका फिर हमारा आंसर आ जाएगा 10/30 which is 1/3. इसमें कोई प्रॉब्लम तो नहीं है?
No.
ठीक है. So we'll move on to the next question. An urn contains 6 white and then 9 black balls. If 4 balls are to be randomly selected without replacement, what is the probability that the first 2 selected are white and the last 2 are black? Okay, so I guess easy question है थोड़ा. So we have total 15 balls. And first 2 are white, so it becomes 6/15 into 5/14. And then the last 2 are black, so 9/13 and then 8/12, which will be 30 into 72 divided by 32760. And this should be 6/91. I'm hoping ये वाला भी easy था, so we can move to the next one. So I'll just check decimal में, ठीक है, 0.065. The king comes from a family of 2 children. What is the probability that the other child is his sister? अच्छा, हमें given है कि एक child तो male है, king है, and then second child sister. So second child is sister and then given that 2 children है और उनमें से एक king है, the other can be a sister or it can be a brother. And I guess it can also be कि पहले सिस्टर थी और फिर किंग था, ठीक है। सो वी हैव ये वाला पॉसिबिलिटी एंड ये वाला पॉसिबिलिटी इन द न्यूमरेटर एज वेल। सो चांसेस हैं कि पहले किंग था, हाफ बॉय एंड देन हाफ फॉर अ गर्ल, and then same thing कि पहले sister थी, so half for a girl probability and then half for the king divided by same probability because ये दो situations do count in the total probability of the two children, and then can be कि it was the king and then the brother, मतलब दोनों boys थे तो no gender difference, तो हमें rearrange नहीं करना कुछ। So we get 1/4 plus 1/4, which is half. And in the denominator, we give half plus this is again 1/4, which becomes 3/4. So half divided by 3/4 becomes, unless I'm doing something wrong, 2/3, ठीक है। Was this also okay?
Yes.
Okay, then we can move on to the fourth question. A couple has two children. What is the probability that both are girls if the older of the two is a girl? ठीक है. Both girl. Given that the older one is a girl, so this one can be a boy or a girl. So both girl में we have half into half, and then it can be both girls or it can be a boy. And then agar should come out to be 1/4 divided by 2/4, which is half. So this is the probability that the eldest child is a girl. And then this is both are girls. Moving on to the next question. 2% of women age 45 who participate in routine screening have breast cancer. Okay, so probability of having breast cancer is, let's do C. Probability of cancer is 0.02, which is 2%. And 90% of those with breast cancer have positive mammographies. ठीक है, so जिनको है कैंसर उनमें से given that cancer है mammography positive होती है is 0.9, 90%. 8% of the women who do not have breast cancer but also have positive. Okay, so mammography positive है given that cancer नहीं है, which is 0.08. And then given that a woman has a positive mammography, what is the probability that she has breast cancer? ठीक है, so हमें इसके लिए चाहिए intersection of C and M and probability of M अकेले. So this we can also find from the probability MC into PC, because this, change the color, is just P C M over P. Oh yeah. So हम इस चीज को फाइंड करने के लिए just cross multiply. तो उसके लिए we have 0.9 into 0.02 for the numerator, and then यहाँ पे 20 खत्म हो गई है या सो ये हमारा न्यूमरेटर आ गया एंड देन PM इज प्लस PM पॉजिटिव मैमोग्राफी दो केसेस में हो सकती है, या तो आपको कैंसर है और फिर पॉजिटिव आया विच इज दिस, एंड या आपको नहीं है एंड देन फिर भी आ गया. सो दोनों केसेस को कंबाइन करके हमें प्रोबेबिलिटी ऑफ हैविंग अ पॉजिटिव मैमोग्राफी पता चल जानी है. सो फॉर दैट since we know कि कैंसर की है 0.02 which is 2%, the probability of not having breast cancer is 98%, which is 0.98. So this becomes 0.9 into 0.02 and ये हमें दिया हुआ है 0.08 into 0.98. And when we solve for this, we'll get the answer, which should come out to be 0.186722. Invalid questions mein one thing we can do is maybe draw a tree diagram so that we know okay, I don't know what's happening. I'll just change the color. Okay, so for cancer it was 0.02. So for not having cancer, we know it should be 0.98. If cancer hai, तो positive mammography 0.9 and then negative mammography 0.1 क्योंकि दोनों should add up to 100%. and then इसी तरह कैंसर नहीं है तब भी positive mammography आ सकती है. we know कि उसके chances हैं 8% and then नहीं है कैंसर और नेगेटिव आई है उसके चांसेस हैं 92%. and then we can just use this diagram to answer this question as well. Moving on to the next question. Consider two coins, a regular fair coin and a two-headed one. Both sides are head. Okay, pick a coin at random. So the probability of picking one of these coins is half because I'm randomly pick kar rahe hain, and then we toss it. If its top side shows a head, what is the probability that the other side is also head? So probability both heads given that top side is a head. So probability of having both heads is K. First, the probability of picking the coin, which is two-headed. Okay, यहाँ पे तो यहाँ ले जा. Okay. So पहले हम वो coin pick कर रहे हैं जिसके दोनों side पे head है क्योंकि हमें दोनों heads चाहिए. And then probability of picking that coin is half because we can pick either of the two coins. And दोनों side पे head होने की probability 1 है because it's a double-headed coin. तो ये ज़रूरी है कि दोनों sides पे ही head होगा. And then for denominator, पहले हम given that the top is head, now दो possibilities हैं कि other side भी head है या other side tail. अगर other side head है तो हमने इसका मतलब with half the probability double-headed coin pick किया था. And then both sides were head, or we picked the other coin which was a fair one and then one side was a head and other side was a tail. So this should come out to be half plus I think I'm doing something wrong here. Should be just 1. Okay, so 2-headed coin was picked. हमारा event है. Give what the hell? Okay, sorry. हाँ, correct. And then second was के top side shows head. So हम base का ही rule use कर रहे हैं and we know कि both head आने की ये probability है.
I guess नीचे वाले में ना आपने 3 दफा 1/2 की और 2 दफा करना.
Oh, okay, yes, you're right. Probably सिर्फ यही था. ठीक है, thank you so much. हाँ, ठीक है, because हमने half से pick किया and then probability दूसरा side tail है क्योंकि हमें already पता है कि एक side half है. ठीक है, you're right. And so this comes out to be 2 over, wait, no, shouldn't be 0.5 into 0.5 is 1 over 4. So ये आ गया half divided by 3 over 4, which then becomes 2 over 3. ठीक है. And then we have the 7th problem. Factory A produces 50% of the output, so 0.5, and its defect rate is 1%. तो defect करा है given के factory A ने produce करा, it's 0.01. Factory B produces 30%, 0.3, and defect rate is 0.5%. तो given that B ने produce करा, defect था 0.005, and finally factory C produces the remaining 20%, and then the defect rate is 0.2%, which is 0.002. An item is picked randomly. What is the probability that it came from factory B? Acha, isme to we don't even have to solve. It's given in the question already. So for part B, we पहले space insert कर देते हैं, otherwise it won't let us. So an item is picked randomly. What is the probability that it is defective? ठीक है, total probability का rule use करेंगे हम. We know it can be defected in 3 cases. के पहले if it's produced by A, then it can also be defective if it's produced by B, and then the same for C. So we should do this for A, then it will come 0.01 into 0.5 plus 0.005 into 0.3 plus 0.002 into 0.2, and it should come out to be 0.0069. ठीक है, and then part C is a randomly picked item was found to be defective. Find the probability that it came from factory A. Given that it was defective, हमको find करना है कि ये A से आया है, so we need the intersection and the probability of this हमें B में मिल गई है. This we can also find through base conditional probability का rule use करके. So given that it's from A, the probability that it's defective is 0.01, and the probability of being produced by A is 0.5, and हम probability of being defective ऊपर वाले part में निकाल चुके हैं. So putting that into the calculator, we get 0.7 2, 4, 6. ठीक है. And I hope this was also clear. Varna, you can ask me. इसके बाद I think we have the last. No, okay, so we have 2 more questions. Sorry. Okay, I think you said it's okay, right?
Yes.
ठीक है. You ask your neighbor to water a sickly plant while you're on vacation. Without water, it will die. So given that कि water नहीं दिया, वो मर जाएगा is 0.8. With water, it will still die, okay. But with a probability of 0.15, we are 90% certain that the neighbor will remember to water. So he will not remember to water should be 10%. Again, we can just make the tree diagram. Okay, water, did not water, and then if you water it and it dies is 0.15. If you don't water it and it dies is 0.8. Don't water it and it doesn't die is 0.2, and you water it and it doesn't die should be 0.85. ठीक है. So what is the probability that the plant will be alive when you return? So it's not dying, which is like D complement is just it is alive. So इसके लिए we have to find the total probability. Okay, this is easier if we follow the tree diagram. It doesn't die and we follow through, it doesn't. ठीक है. तो इसमें we have 0.8. okay, पहले इसको फॉर्मूले में कर देते हैं. Given that you watered it, oh, okay, yeah, it's working now, and it doesn't die, into the probability that you watered it. And doesn't die given that you did not, the neighbor did not water it, into the probability the neighbor did not water it. So we should be getting 0.85 into 0.9 plus 0.2 into 0.1. ये हम follow कर सकते हैं tree diagram से, as I have told. तो ये वाली probability is this one, and then ये वाली probability is this one. So our answer should come out to be 0.85 into 0.9 plus 0.2 into 0.1, so 0.785. ठीक है. And we can go another way. अगर tree diagram किसी को नहीं आती है या कोई problem है कि we can just find the probability of the plant dying and we can subtract it from 1, and we should get the same answer. तो हम कर ही लेते हैं इसे. So probability that the plant will die, दो scenarios हैं. You did not water it and the neighbor did not water it, sorry, and it dies. Or the neighbor did water it and it still dies. So this should come out to be 1 minus 0.8 into 0.9, no, 0.1, sorry, plus 0.15 into 0.9 And again, we can just put it in the calculator and get the same answer, I think. I'll just check also. Yep, 0.7850. Part B है, if it is dead, what is the probability that your neighbor forgot to water it? तो अब हमको पता है कि मर गया है plant, so we want to know कि उसने water दिया ही नहीं था. So we want the intersection of this over probability of it dying. Probability of it dying is, अभी हमने find out किया ऊपर वाले part में, either this was the probability of it being alive, so हम 1 minus this कर सकते हैं, or this is just the probability of it dying. इसको direct we can just put in here. So we should be getting 1 minus 0.785. Oh, sorry, in the denominator. And in the numerator we should get, okay, हम वापस से probability का rule use करके ये intersection मालूम कर सकते हैं. It should be 0.8 into 0.1 divided by 1 minus 0.785, which is 0.215, which is also the probability of it being dead. तो हमारा आंसर आना चाहिए 0.3721 base का rule use करके. And then we have the last question. ठीक है. And one contains 2 white balls and then 1 black ball, while urn 2 contains 1 white ball and 5 black balls. 1 ball is drawn at random from urn 1 and then placed in urn 2. Ball is then drawn from urn 2. It happens to be white. It's a given that the ball is white. Ball is white from urn 2. What is the probability that the transferred ball was white? So, ठीक है. So ball from urn 2 can be white in 2 cases. जो कि हम अच्छा ये बहुत बड़ा है ना, तो इसको हम event B बोल देते हैं और इसको हम A बोल देते हैं. So we want probability of B, probability of A intersection B. So we get ये transferred ball अगर white थी, तो हमने पहले वाले में pick white की थी, तो which is 2/3, एंड फिर हमने उसे ट्रांसफर करके जब दूसरे वाले से उठाया तो दूसरे वाले में 2 वाइट बॉल्स थी, तो 2, और टोटल नंबर ऑफ बॉल्स थी 7, क्योंकि हमने एक ट्रांसफर कर दी थी. दिस इज आवर न्यूमरेटर. एंड देन इन आवर डिनोमिनेटर सेम चीज़ कैन हैपन कि हमने वाइट उठाई थी, हमने उसे ट्रांसफर कर दिया था, और फिर हमने दूसरे से वाइट उठाई, या फिर हो सकता था कि हमने ब्लैक उठाई थी एंड हमने वो ट्रांसफर कर दी, एंड फिर हमने दूसरे वाले से जब उठाई तो अगेन तो नहीं, तो वो वाइट निकली. सो दिस शुड गिव अस 4/5. I think that's it. So you don't have any question, right?
मैंने अभी ना एक देखा था, वो होमवर्क को देखा थोड़ी देर पहले, तो मुझे एक क्वेश्चन था कि जो आप यहाँ पे है कि E is a subset of F and F is a subset of E, तो उस केस में आप बता सकते हैं प्रोबेबिलिटी क्या चेंज आएगा कि अगर एक इवेंट दूसरे का सबसेट हो.
ओ अच्छा, इस वाले की अच्छा ना, ये मीटिंग 8 मिनट्स हैं, तो वी हैव इनफ टाइम. ठीक है, जस्ट आई इंसर्ट सम स्पेस, आई गेस. एक अच्छा wait, I'll just stop the recording and then I can